Hello, everyone. This is Professor DePaulo. Welcome you back to behavioral statistics, and we're going to be doing some online problems in preparation for the final exam. And we're going to start with a couple problems on the ANOVA summary table. So I'm going to go into Microsoft Whiteboard, and we're going to look at a couple problems. How to solve the ANOVA summary table, which will be part of the multiple choice items. So let's say we have a problem like this. So the table shows ANOVA and ANOVA, right? Comparing, so we're talking about what the ANOVA summary table is doing. 3 treatment groups. With 10 people. Sorry, the E is off here. We're gonna fix this. That E looks bad. So there's 3 treatment groups, there's 10 people in each treatment group. Three treatment groups, 10 people in each treatment group, right? So a total of 30 people. And what is the missing value for sum of squares total? What is the missing value for sum of squares total? So here's what it looks like. We got between, we got within, we got total. There's sum of squares here. Between group sum of squares is 20. We don't know any of this. We don't know the degrees of freedom. We don't know the mean squared. We know the F ratio is 5. So we got to find SS total. So let's fill in what we can fill in at the beginning, which is the between groups degrees of freedom. We know that the between groups degrees of freedom is k minus 1, where k is the number of groups. Well, we have 3 groups, so k is 3. K minus 1 then becomes 2. So the degrees of freedom between is 2. We then know that 20 sum of squares divided by 2 degrees of freedom gives us 10 mean squares between. So we have finished off the mean squares between. We need to do the mean squares within. We need to at least find the mean squares within sum of squares, right? Sum of squares within to get the sum of squares total. So we knew that the degrees of freedom for between is k minus 1. So in this case, it was 3 minus 1 is 2. We know that the degrees of freedom within is n minus k, where n is the total sample size. We know that the total sample size is 30 because there's 3 treatment groups with 10 people in each group, so we know that's 30. Minus k, which is 3, that gives me 27. So I have 27 degrees of freedom within. And when I add 2 and 27, I get 29 total degrees of freedom. Now, we also know that if the F ratio is 5, right, F is mean squares between divided by mean squares within. And then if F ratio is 5, so then 5 equals mean squares between is 10 over mean squares within, right? So that's 5 times mean squared within equals 10. Divide both sides by 5, right? And mean squares within is 2. So we know that the mean squares within here has to be 2. Because 10 divided by 2 gives you 5. we can then multiply backwards. We know that sum of squares is equal to mean squares times degrees of freedom, right? So we see this with between. 10 times 2 is 20. So 2 times 27 has got to be 54. 54 divided by 27 gives me 2. 20 divided by 2 gives me 10. The answer of 10 divided by 2 gives me 5. So we're done with almost everything. We have to add up the sum of squares. 54 and 20 is now 70. The little line for the sum. So we've completed the ANOVA summary table that was missing some data. Now we're going to go and try this again with a different summary table, another example. So in this example, the table, the ANOVA summary table, shows ANOVA comparing three treatment conditions with 7 people in each treatment group. What is the value from mean squares between? What is the value for mean squares between? So that's a question. Here's what we have. We have source. We have between. We have within. And we have total, of course. Then we have a sum of squares column, and this is what we have. We have 20 here. For between group sum of squares, the degrees of freedom, the only thing we have is within. Within is 2. And we don't have the F ratio. So we need to find mean squares between. Actually, let's put the mean squares column in here. We don't have any of the mean squares column in here. So we have a mean squares column, right? And then F. And we don't know any of that information. So all we know is 2 and 20. Well, the first thing we can do is find the total sample size. So there's 3 conditions, 7 each treatment group. 3 times 7 is N. N is 21. So it's 21 total people. We know degrees of freedom between is K minus 1. K is the number of groups. Here we have 3 good conditions, so we have 3 groups. So degrees of freedom between is 2. So 2 degrees of freedom between, 2 degrees of freedom within. So here we have mean squares between. 20 divided by 2, mean squares between is 10. Actually, the mean squares, the degrees of freedom within is not 2. I copied it wrong. The MS with it is 2 instead. So that makes more sense. I was looking at it and I transcribed it incorrectly. So 10 divided by 2 for the mean squares gives me F. F is 5, right? But we still need sum of squares within. We know the degrees of freedom between is 2. We have that. And degrees of freedom within is going to be N minus K, N being 21, K being 3. That gives me 18. And obviously, total degrees of freedom is 20. And then 2 times 18 gives me 36 for my within groups. And the total is 56. And my ANOVA summary table is done, and the mean squares between is obviously 10. And that's kind of how we deal with these ANOVA summary table problems. We work with the degrees of freedom. That's probably the most important place to start. And then we kind of work backwards from F to mean squares to get back to the sum of squares. So hopefully that helps. And you'll see a couple problems like that on the exam in the multiple choice. Bye for now.